So welcome for our today's lesson. So we'll continue where we ended, which is the tension force. So this will be a short lesson. How can we calculate the tension force like this one? So this is an object, right? When you look at here, this is an object which we have. This is an object. Now we have this rope attached here. When this rope is attached here, what is happening here? This rope is attached by a mass with these two ropes. Now they tell you calculate the tension, which is T1 or T2. How can you calculate the tension? Then this is mg. So what should you do to calculate the tension? Let's start with a new. So they will give you questions like this. It hangs on a rope like this one. This is a simple question. So they will ask you a question like this to calculate the tension. This is the mass. If this is the mass, right, then it is hung by this, which is the tension force. How can you calculate the tension force? So this is simple. The only thing which you need to know the tension acts downward. We say, remember what we were saying on forces. We are saying that this force, this is a tension force, acting what upward, then downward because this is the mass. Acting what? The mass is acting downward because of the weight. There we said this is in y-axis. So we were saying that to calculate here the tension, we were saying that to calculate the normal, we are saying that the normal force it is mgy. It's similar to the tension there. So the tension is acting upward. So the forces, I explained that the forces are categorized in x and y direction. The tension there is the force attached with this spring. That is what we're calling the tension. So the tension there force is acting what upward. So it's acting upward. We say tension minus, because this mass is acting downward due to the weight, which is mg. Mass times is equal to, since this is not moving, we are saying that the summation of forces in y is equal to what? 0. So we have in y-axis we have two forces, which is the tension which is acting upward and the mass which is acting downward, which is the weight. So that's why we say tension minus mg, because mg is acting downward, is equal to the summation of forces, which is 0, in y-axis, which is 0. So the formula for tension is equal to what? Mg will go this side. So tension is equal to mg if they have given you this question. Now let's go to the difficult question. So this is our first question. Let's go to the difficult question. Now we have two ropes. This is the ropes, and we have this tension. From here, this is tension 1, then this is tension 2. How can we calculate the tension 1 and tension 2? I like this question because it requires you to relate the knowledge which you have on forces. Yes. So it is simple and easy. Don't worry, I'll help you to understand it. Yes. So if they have given you that question, this question, right? It hangs there the ball. I'll explain all the concepts which you need to know here. So first thing, they will give you the angle. So the angle here, it is theta. Even here it's theta. They'll give you angle here. But so this is what we call tension 1. This is tension what? Tension 2. So this is tension 1, this is tension 2. Then the angle here, which is theta, and here is also theta, right? Now they tell you calculate the tension 1 and tension 2. How can you calculate tension 1 and tension 2? So this is simple and easy. So you just need to allocate into component. There, we will allocate into component. So we have this tension is going what? Upward. Even this tension is going upward at an angle which is theta. So the first thing there, allocate into component. If you are starting with the tension 1, let's start with tension 1. Here, according to vectors has the y and the x component, even the direction of vectors. We are saying that, let's give an example what we are doing in vectors. So in order us to go from point A to point B. So how were we moving x and y component in vectors? So this is B. So we were moving like we were moving going this side, then also going upward. So even here on forces matters the direction. Since the tension there, the force is acting on the lobe, is going upward. Even as we move, we go this side, then also we go on top, just as we were doing in vectors. So remember, we are saying that forces, it's also what we consider as vectors. The same topic in vectors, it's the same thing we need to apply on forces. Yes. Now, when we allocate this is tension 1, right? Then this is tension 2. It has the tension 1 here. It has the x and y component. So how can you find here the x component? The x component y is equal to what? We were saying that when we are calculating here the resultant, we are saying what? R cos theta. So for x, we are saying x is equal to R cos what? Cos theta. So similar here to tension from here. So we say this is tension 1. So we say tension 1, then this is what? In x component. You are saying you want to find the x component, right? For tension 1, which is T1, T1, which is cosine theta. Then also in y component for tension 1, which is T2 sine theta. That is the key thing which you need to know. X component is T1 cos theta. Y component is T2 cos theta, because here it has x component here and also y component. So this is tension 1. Even tension 2 has also tension 2 here. When you look at tension 2 here, it has the x and y component. So the tension 2 is equal to, so x to the component 2 is equal to T2. Yes. So this is tension 1. It's the same as here. So we are saying it's T1 sine what? So T1 here we are saying T1 sine theta for y component, like here. So it's T1 sine Ty sine theta. So for tension 2 there, so we say tension 2 there, then we say cos theta. Even y2, so even y2, so y2 will be what? Will be T2 sine theta. I hope it's clear. So when you allocate this into component, then it will help you to answer any question they will ask you, whether in an exam, whether in tests, quizzes. It will be very much easier for you. So first thing, allocate into component. Then let's move on. How can we calculate the tension? Let's move on. So okay, so we are moving on. So like this. So we are saying this is our tension what? Tension 1. This is our tension 2. Now remember what I said. I said what? I said the summation for forces acting in x is equal to 0. The summation of forces acting on y is equal to 0. Remember what I said when we started learning on forces? Because here tension, the object is not moving here. Yes, the object is not moving. Then we have allocated in two components, right? We have allocated in two components. So what are the forces acting in x-axis? So we start with x-axis. So the forces acting in x-axis. So what are the forces? So we know the forces which are acting on the x-axis. It is this arrow going this side. So we said this is what? X component, right? This is tension 1. This is x component. So the forces which are acting on the x component, which is tension 1 sine, or it's cos, sorry. So tension 1 cos theta. You learned this, the component. So it's tension 1 cos theta plus what? So here, when you look at here, what is happening? This side, we are saying that the direction here, the direction for tension 2 there, this is tension 2. The direction for tension 2 is going this side, right? So, since according to vectors, so we are saying that how do we move according to vectors? So we move this side and we go up this side. So since it's going this side, it will be minus. Yes. Remember in vectors, because it's going this side, it will be minus. So those are the forces which are acting in what? In x-axis. Those are the forces minus tension 2. So tension 2 cos theta. So those are the forces which are acting on x-axis. Yes. So it is simple and easy. So minus E tension 2 cos theta. Yes, that is the only thing which we need to know. What about the forces which are acting in Y? So you just allocate into component. When you allocate into component, then try to know, you need to know also the forces which are acting on x-axis and the forces which are acting on y-axis. So what are the forces which are acting on y-axis? So when you look at here, we have going the tension they are going this side, even the tension they are going what this side. So these two forces, they are going to positive axis because they are going on top. Yes. So tension one, so tension one sine, so which is tension one sine what? Sine theta, plus tension two sine theta. Now here downward there is a force also, which is mg. So there is a force acting downward, which is mg. So we subtract minus mg. So the tension force which are acting there, there is a downward force which is the weight of that object which is hanging, which is mg. That's why we subtract minus mg. Now we know that we know this question. We know that here the summation of forces acting on x and the summation of forces acting on y is equal to what? Is equal to 0. So here it's 0, even here it's 0. So if you do all these things which I've explained here, so any question they'll ask you, you get it correct because you have already answered the question there. Even you have already calculated tension 1 and tension 2. So what remains is what? It's just to answer. Yes, it's just to answer because you have answered the question. Now, how can we calculate the tension 2 and tension 1? Tension 2 and tension 1. So first thing there, you just calculate. We know that mg. Okay, let's go to the. So the second thing which we need to know, you just need to calculate. So we have given that the summation of forces acting on x, we say it's tension 1 cos theta minus tension 2, so tension 2 cos theta. Then also the summation of forces acting on y-axis, which is tension 2 sine theta plus tension 2, sorry, tension 1 sine theta, tension 2 sine theta minus mg. Now, what remains here? If they have given you this question, you have already calculated this. You just need to replace. They will give you theta and the angle there. They will give you theta and the angle. Even here, tension 2, they will give you theta and what? An angle. So, here, what you need to do here, tension 1 cos theta. So, there, you write tension 1, then cos theta. If they have given you that angle, just calculate, punch it. If you punch it, it will give you like, I'll give an example. Maybe it give you 0 point something. Maybe it give you like 0.2, right? Then minus tension 2 there, you calculate, it give you tension 2, give you like 0.1. I'm just giving an example. Even here you calculate, it's giving you what? Tension 2, the tension sin theta, maybe it give you like 0.3 minus tension 2 sin theta, it give you, so write tension 2, give you here, maybe it give you 0.8 minus mg. Even they'll give you mass and also the gravity, you know, mass. If they give you a mass, you just replace there, it will give you like example like giving you 0.9. Now when you calculate here, it's, so when you look at here this question, you can relate this to Pythagorean theorem because you know this. So this is a two. You can relate this to simultaneous equation. You know simultaneous equation, right? Yes, you learned this in grade 9, 10, 11, 12. So you have two equation here. You can relate this to simultaneous equation. Yes. So 0.9 will go this side. 0.9. 0.9. So here will cancel because here it will be plus here. So then you have two simultaneous equations. You can use any method to calculate here simultaneous equation. If you like substitution method, you can get this T2, go this side. So T2, then you replace on the equation. So this is simple. That is how we calculate the tension. So here you calculate the tension 1 and the tension 2. You calculate it. So you have calculated the tension 1 and tension 2. So that is the one thing which you need to know to calculate tension 1 and tension 2. Using simultaneous equation there, you can calculate the T1 and the T2. So it is simple and easy. So if you have any question, you can you can write on the comment section. You can like our video, you can like the video and also subscribe to our channel, to our YouTube channel.